All right. Welcome back, everyone. Ready for another deep dive.
Always ready to dive in.
So today we're tackling a math problem. You know, those systems of equations. Someone wrote in asking for help with one.
Ooh, yeah, those can be tricky.
This one is, it says, 6x plus y equals 25. And then 2x minus 3y equals 25. And we're supposed to solve for x and y.
So two unknowns and two equations. We can definitely work with that.
Right. And the source even gave us multiple choice answers, but...
Shh. Who needs multiple choice?
Right. Let's actually figure this out.
Yeah, let's understand how to get to the answer ourselves.
So what's the first step? When you see a system of equations like this, where do you even begin?
Well, there are a couple of different approaches, but a good one here is elimination.
Elimination, huh?
Basically, we want to combine these equations in a way that gets rid of one of the variables so we can solve for the other one. It's kind of like, I don't know, imagine you're trying to find a specific spice in a recipe. You might try to get rid of the other ingredients first.
Okay, I can see that. But how do we actually eliminate a variable? These equations look kind of stuck together.
True. We might need to tweak things a bit first. So take a look at the y terms in each equation. See how one's positive and one's negative.
Yeah.
What if we could make the numbers in front of them, the coefficients, opposites of each other?
Ooh, you mean like a plus 3y and a minus 3y?
Yeah.
Because then they'd cancel out, right?
Bingo. And we can do that by multiplying the entire top equation by 3.
Multiplying the whole equation, won't that change everything?
It changes things, yeah, but in a balanced way. It's like using a bigger measuring cup for your recipe. The proportions stay the same.
Right, right.
So if we multiply that top equation by 3, we get 18x plus 3y equals 75.
Ooh, okay, now we've got that plus 3y.
Exactly. Now the fun part, let's add the two equations together.
All right, so the 18x and the 2x become 20x. The 3y and the negative 3y, they disappear. And then 75 plus 25 is 100. So we have 20x equals 100.
See? It's simplifying already. And that looks way easier to solve, doesn't it?
Definitely. Just divide both sides by 20, and we get x equals 5. We found x.
Awesome. Halfway there. But remember, we're looking for both x and y.
Right. We can't leave y hanging. So how do we use our newfound knowledge of x to figure out y?
We substitute. Now that we know x is 5, we can plug that value back into either of the original equations.
Like we're swapping out a puzzle piece.
Yeah.
Okay, let's try it with the first equation. 6x plus y equals 25. So 6 times 5, that's 30, plus y equals 25.
Looking good.
Then subtract 30 from both sides, and we get y equals negative 5.
Boom. We did it. We solved for both x and y.
That felt kind of satisfying, actually.
Right. You cracked the code.
So just to recap, we used elimination to get rid of y, solved for x, and then substituted to find y. It's like a little dance of algebra.
It is. And you know what's cool about systems of equations is they're not just some abstract math thing. They have real-world uses.
Oh, yeah. Like what?
Think about figuring out the best deals at the grocery store, or balancing your budget, or even, designing structures and engineering. Systems of equations can help us solve all sorts of problems.
Wow. So it's not just for textbooks. It's a tool for understanding the world.
Exactly. And you know what's even cooler? We could have solved this problem another way, by graphing.
Graphing? How does that work?
Well, each of these equations can be represented as a line on a graph. And the solution, where x equals 5 and y equals negative 5, that's the point where those two lines would intersect. It's a visual way to see how both equations are true at the same time.
Ooh, that's interesting. I might have to try that later. I always liked graphing.
It's definitely worth exploring. There's always more than one way to solve a problem, whether it's math or anything else.
That's a great point. And it's a great note to end on. Thanks for this deep dive. It was illuminating.
Always happy to geek out about math.
And to our listeners, keep those questions coming. We'll be back with another deep dive soon. Until then, keep exploring.